Hi, it's Bruce again, and welcome to my Colorado Rocky Mountain lab, where today we're going to take a look at a Hewlett-Packard 461A amplifier, or I would call it maybe a wideband preamplifier, but this is a amplifier that's capable of producing a gain of 20 or 40 dB, which is 10 or 100 times gain. Selectable from the front panel, we got 50 ohm input, 50 ohm output. It's in a nice, attractive, small-sized case with a wire baling. And so you say, well, what use would it be for me? Well, they're excellent preamplifiers to amplify signals that otherwise would not be able to drive, say, your frequency counter. Would not display well on your oscilloscope. Maybe is beyond the range of your oscilloscope and you need to boost up the signal to be able to still see it. All of those are possibilities. Or maybe you need to amplify a signal from a board such that you could hear it. Or it's a radio frequency coming in that you need to amplify. All of those things are capabilities of this thing. But let's go ahead and give an example. Frequently, well, let's try that first. Here's I'm looking at 20 megahertz coming out of my generator right now, and I'm going to connect up to my Philips frequency counter and see if we can. No, don't have enough signal there to be able to drive it. Why is that? Well, because I'm working with about 3 millivolts of signal. Just not enough to push this doggone thing. So, what if I instead hook this up to my preamplifier, get an output out of it, go to the input now of my counter. And wow, I didn't even have to do anything, and it's there counting. There we go. A little bit more. All right, so we're getting 20 megahertz on the counter. The only way I was able to read it, I had to preamplify it. Let's take a look at the scope. All right. I am seeing on the scope right now about one cycle in a centimeter or division, and I'm at 50 microseconds per division. So one cycle in 50 microseconds is 20 megahertz. But what kind of an input am I getting on this thing right now? Well, let's take a look at the input. Okay. My input is down to the 5 millivolt per division setting. And okay, so we've connected up to channel 1. We are at 50 millivolts per division. We're up 50, down 50. We were up 5 and down 5 on the input, so we've got a gain of 10 here. If I go to 40 dB again, then I can step up my input. Now I'm on 0.5 volts per division, and I'm up 0.5 volts. So I went from 5 millivolts to 0.5 volts. That's a gain of 100. So we're getting that just fine too. Let's take it down lower. Okay. What am I working with now? Can I see it? No, by golly, it's just not gonna sync. So I can't really see the signal. Well, almost. There it is, just barely coming in. Looks like I'm might have been looking at 1 or 2 millivolts, but I can't tell for sure. So let's go ahead and take this lead from the generator, feed it to the preamplifier. We're coming out of the preamplifier, we're going back up to the scope, and we are now seeing a 0.2 to 0.2 volt rise and fall, so 0.4 volts peak to peak. And we're seeing it plain as day. And we're seeing one cycle, and it's still 20 megahertz we're seeing. So even though we couldn't see it on the input, we're seeing it on the output, and I'm at the 40 dB setting, so I'm times 100. So I must be putting in about 2 millivolts peak, and I'm getting 0.2 volts out. So there's a good example of what that's useful for. Now, what if I turn up my frequency to something that my scope is not supposed to handle? All right, here's 150 megahertz. That happens to be the limit that is mentioned on the amplifier. I am going to adjust. Okay, so we've got the 150 megacycles coming to the HP amplifier from the generator. And I'm coming out, going to my 100 megahertz scope. So this is 50% more bandwidth than what I should be able to read. But I'm counting 1, 2, 3 cycles in a division at 20 microseconds. So getting 150 megahertz. So that's a 150 megahertz signal on the scope. I can see it, I can count it. It's working good. Maybe I can make that a little more visible there for you. Okay, so here we're feeding a 50 megahertz signal out of the generator. And we take a look at the input directly from the generator and see if we can lock it in. All right, we got it locked in. It appears that we are running, we're on the 5 millivolt 5 millivolt per division scale, and we're going up about 3/5 of the division. So that's about 3 millivolts out, 3 millivolts peak. So we're up and down 3 millivolts, 6 millivolts peak to peak. Let's go ahead and take a look at the amplified output. We just plugged into the input here. We're on 40 dB gain. We're going to go back to trigger on channel 1 and let's lock ourselves in. Okay. And we see that we are going up and down about 1.5 divisions at 0.2 volts per division, which would put us at 0.3 volts up and down. So gain of 100, which is what we would expect, 40 dB. If I was to reduce that to 20 dB, I should see myself fall to half of that. All right. So again, I should see myself go about 1.5, which if I drew a line through the middle of the fuzz on the ends, because we got some noise here, we would be about 1.5 up and down again. So worked out better at 40 dB because I didn't get the noise problem. But we are getting times 10 times 100 type scale, and we are able to read it better on the oscilloscope. So it's an excellent preamplifier. It's got all of the nice little features. You could build one for yourself, perhaps, and that might be fine if what you want is the challenge of doing that. Don't forget that you need to have an excellent case. A case like this would run you at least $50 if you could find one. And this one comes already assembled, has the inputs, has the gain switch, has the plug, the fuse, everything you need, the wire stand, and it's done. And it works fantastic. So you got to consider that. At this price, you could not build it. If you want the experience, go for it. I've done that too. But if you want a really nice Hewlett-Packard amplifier for your bench, it'd be very utilitarian for your needs for meters and oscilloscopes, this might be it. Thanks for listening.